Hello, these are our solutions for our Unit 2 practice test. As we go through, I'm going to hold up a little card here for you guys to know what the answer to each question is so that you can skip ahead if you got the question right and you don't feel like you need to hear the discussion behind the problem. I only have about 20 minutes to record right now, so I may split this out into 2 different videos just depending on how long it takes me to get through each section. So we'll start at number 1. Oh, sorry, I just moved it out of your view. Okay, so range, I just went through for the different stem plots and actually calculated the range. It's the max minus the min. So the range for the females is 14, but the range for the males is 15. Then for standard deviation, the female distribution is skewed right, but the male distribution is roughly symmetric. Because of the skew, the standard deviation is going to be greater for the females because it's skewed right. So it has values on the higher end that are going to distort your standard deviation and make it seem bigger than it really is. We know that most of the data values are probably centered around the mean. These data values there are some being pulled away from the mean. So standard deviation on a skewed data set is going to be bigger. This is our next one. Okay, on this one, make sure that you're really careful and noticing that this says which one is not affected by outliers. Mean considers every data value. You add up every value. Median is one number. Standard deviation, you need to find the deviation of every value. Range is the max minus the min. Interquartile range is the middle 50% of the data. So the only 2 that are not affected are median and interquartile range. Range is definitely affected because the max or the min will be an outlier. Standard deviation and mean take into consideration all data values, so they are affected by outliers. Okay, on number 3, I'm actually going to grab I'm just grabbing a practice test. So on number 3, it says the lowest allowed GPA, a 2.5, at the lowest allowed GPA, the NCAA requires Division I and Division II athletes to score at least an 820 combined score on the SAT Math and SAT Verbal. At that combined SAT scores, assuming that the combined scores have a normal distribution with a standard deviation of 200, what is the mean if it is known that 83.65% of all students scored at least 82? Well, this is actually a percentile question, and in your flashcards, I made a card that has to do with the most common percentiles when it comes to the normal curve. Now notice, they didn't give us 84, they gave us 83.65, but the fact that that is so close to 84 made me think I probably have to use this idea. So, what we know then, based off of that, is that if I have a normal curve with mu in the middle, 1 sigma is going to be the point at which 84% of the students are below it. Now, 83.65 and 84 are close enough. Well, then what does that tell us? That tells us then that this point is 820. Because it says almost, so I'm going to read it this way, almost 84% scored at least 820. Uh-oh. So this is backwards, so maybe I did this wrong. Pause. I think I might have did this wrong. I did do it wrong. So I missed the point where it said they scored at least 820. At least 820 means that the minimum is 820 and that they could have scored more than that. So what that means is that instead of being at 1 sigma, I'm at -1 sigma. Because at this point, 16% scored less than or equal to 820, which means that this is saying 84% scored greater than or equal to 820. Now, I know that it's weird for me to use a less than or equal to both times, but that's okay. Don't let that trip you up. Just see if what I'm saying here makes sense. This idea where I have to acknowledge that 83.65 is pretty close to 84 still applies. But what I missed was if it's at least 820, that means that 84% is above that flag. So this means that this flag is 820. But we know standard deviation. They tell us that standard deviation is 200. So if this is 1 standard deviation below, what I need to get to mu is to add 200 to this. So that will give me 1020. And then over here, which one of these is the closest to 1020? E. So the answer to number 3 is E, not A. E, not A. Next. Okay, on number 4, Bill scored 10 fewer points than Jane. Nope. It's percentile, so it doesn't tell you the amount of points. It tells you the amount of data below, less than, or equal to Bill. The average score of those that were between Bill and Jane is 81. Nope. Bill's score is 10% lower. No. None of the above is true. No. It has to be B. So the biggest thing they're trying to get us to distinguish on number 4 is understanding that percentiles don't give us specific information about the data value, the value of the data point. It tells us how much of the data is below that value. So percentiles don't give us information about the actual data value. It gives us information about how much of the data set is less than or equal to the observation. Number 5. So I just drew this out like a regular data set and went through and actually wrote down where my median Q1 and maximum were. And I did that because it was the only thing that I could think of that would help me. So using my knowledge of interquartile range and breaking the data up into segments of 25%, I have calculated where each quartile is at. So how many or what percent of women is between 110 and 240? Well, notice that 110 is above quartile 1. So I said that the amount of data between this and the highest has to be around 75%. Six. Okay, I did a flashcard on problems like 6. So hopefully that flashcard helped if you saw it. But the mean will increase because Jared Dudley weighs more than the mean. And the deviation will decrease because the standard deviation is 30, but Dudley's deviation is only 16. So standard deviation will decrease. This basically just comes from your notes, the way that you're supposed to word standard deviation. Notice that this does include the word typically. If the definition or the interpretation does not involve the word typically, it probably is not the right selection. You're looking for the word typically or average. Typically or average. The only thing that bothered me about this one was that it really should have said from the mean of 258 copies. Okay, 8. I just calculated the z-scores. So, oh, I think I might have did this one wrong too. If a Ford Mustang, in which year was it more expensive relative to other cars? So this one would actually be less expensive because it's farther away from the mean in the negative direction. And this one is more expensive because it's closer to the mean. So number 8 is not A. It is 2011 because the standardized score is greater than in 1965. Is that true? Well, that's our only option, so we have to. I can see that it's greater in terms of actual value, like negative 0.28 is greater than negative 0.35, but that wording kind of bothers me a little bit. Regardless, the answer is C, not A. Okay, we're getting there. Number 9. Okay, this problem is pretty tricky, and you will see for sure something similar to this on the test. So this distribution here of 100 fastballs thrown by a major league pitcher is approximately normal. And one thing that you have to remember about, or that hopefully you remember about a normal distribution, is that the data has to be within 3 standard deviations. So most of the data. But then the other thing that I want you to notice is that in the tails is like no data. It says 0.15%, but essentially that's no data values. So in a distribution with 100 fastballs, if I multiply that by 0.1%, sorry, that's the wrong one. 100 fastballs times 0.0015, that's less than one fastball. So when you go to find your standard deviation, wherever you lay down your tick marks, there should be no data after your third tick mark. So that being said, I can test these. If the standard deviation is 0.5, that means that your sigmas would be here. This would be 1 sigma, 2 sigma, 3 sigma. So it definitely cannot be A, because look at how much data you have in your tail. You're supposed to have no points and you have a bunch of points. So it cannot be A. So the next one then that we want to check is 1.1. Okay, well that means that our first tick mark's going to be slightly after the 96. And then our next tick mark is going to be a little bit more after the 97. And then our last tick mark is going to be a little bit past 98. Notice in our tail, there is no data like what we would like. There's data in between 2 and 3, and data in between 1 and 2, which we should have. So I'm thinking that it's probably B. But just for good measure, I'll try 1.6. I'm going to go in the other direction though. So 95 minus 1.6 gives us 93.4. So that's here. That's your first standard deviation. And then minus 1.6 is 91.8. So this is 1 sigma, this is 2 sigma, which means that there's no data values between 2 sigma and 3 sigma. So that is also wrong. It's too big. And if 1.6 is too big, then 2.2 is too big, and 6 is definitely too big. So the problem with A was that it was too small. It left data in the tail where there should be no data. And I think I said 1.6, but I meant 0.5. And C is too big because it makes it so that there's no data between 2 and 3 sigma. So it does have to be B. Okay, and then lastly, number 10. Number 10 is a repeat problem that I explained in your Can You Do, so I'm not really going to go over it again. The only thing that I want to mention is, well, 2 things. Number 1, I put it in again because you will see something similar on your test. It won't be exactly the same, but it's going to be very similar. And the thing that you need to recognize is
Haley Austin, Tanea Baker, Alexis Bites, Amir Callas, Oregon.
Annoying.
Olivia Malay, Cameron Peterson, please come to the Counseling Center. I also need Jocelyn.
Okay, I'm just going to talk over her because that's too much. So the one thing you want to recognize is that this standard deviation is bigger because more data is in the tails. Think about it as the flagpole. The middle is the flagpole. Where are all your people standing? Well, most of the people are standing away from the flagpole. Most of the people are standing at the flagpole. So away from the flagpole is a big standard deviation. At the flagpole, little standard deviation. So 2 things to note on this. You will have a question on your test that is similar to this. You have to use the same idea about knowing where the data is in relation to the mean. And 2, you have to know if the data is far from the mean, you have a bigger standard deviation. So I am going to split this into another video. So I'm going to upload this one now, and then I will have, if the free response is not up by the time you're watching this, it will be up shortly. Okay. Good job watching this. Love you guys.